welcome back my dear friends. Today I'll continue with that exercise 5.5. So this is welcome back from the SEN tutorials. I am your sir here, trying to just help you out during this lockdown. I'll just continue with this exercise 5.5 now, question number 6. I hope all of you are doing your studies well at home. Okay, now let's begin. So in the previous video on exercise 5.5, we have seen how to use how to take the help of logarithm to differentiate certain complex functions. Now today we're going to learn one more application, another application of log on differentiating another type of complex functions, another type of functions. Sorry. So now, how is it different from, how is this equations or how is this function actually different from the previous functions that we did? I'll tell you. See, in the previous functions, if you remember, the question was, it was like, for example, it was log of x whole power sine x. If you remember one of those questions, it was log x whole power sine x. So that was quite simple. We used simple logarithmic functions and then we could easily solve. Now, here, how is it going to be different is you have here addition of two functions. You have here like addition of two functions. In the previous questions and all, the difference was you had only one function, just one simple function. In this question, of course, we have like addition of two functions. So are we going to apply log in that same way or is it going to be slightly different? It's going to be slightly different, okay? How is it going to be different? I'm here to help you. Let's study this. Now, you see, if you remember again, the functions, before we did that problem, some of the basic functions on log that I gave you was u into v. So that was like log of u plus log of v. So you must be thinking, sir, you have already given us once again. Why are you giving it again and all? Now, why? I'll tell you. Why am I reminding you of this application is I did not give you any function that was based on log of u plus v. We know that most of you may be knowing that logarithmic functions, they are also not product of these functions, not product of log and u plus v. So we cannot just assume that I will just multiply log of u plus log of v. No, that is not possible, okay? And there is literally no function which will help us define. So now what shall I do? Definitely I'll be making use of the applications of log, but with a small twist. So before I really use that application, what I am going to do will be, I will assume this function to be, since there are two functions here, I'll assume this function to be u and this function to be v. Okay, this function to be u and the second function will be v. This function u and this function is v. So if I apply my differentiation here, del y by del x, so that is going to be del u with respect to x plus del v with respect to x. I will keep this equation for now. Okay. Now what I need is to find y with respect to x, derivative of the function. I'll need to find out derivative of the first function which I assumed to be u, and I'll need to find out derivative of the second function which I assumed to be v. Okay, so we're going to do this separately because again I repeat, if I take log directly I cannot solve, no, because if I take log directly, what am I going to get here? Log y equal to log of this function plus this function. Now that cannot be simplified again because log is not a product, isn't it? So I cannot multiply log of this function plus log of this function. So there my application of log will not help me out because that's not the way it has to be done. So I have just named these two functions separately. So now what I'll do is I'll take the functions separately. That is, u is this function. So now what I'm going to do is I'll take this function separately and then I'll differentiate it the way I want. You can use any of the tools. You have logarithmic tools, any of the tools. It's not compulsory that you always have to use logarithmic tools only. No, you can use any other tools also and then find out u with respect to x, derivative of v with respect to x. Doesn't matter how you do it. Okay, so let's begin. So in that case, what I'm going to do now is I'm going to rub this off. Okay, so that will create more space for me. So I'll write that again. Now u is going to be equal to x plus 1 by x whole power x, a function of a function, again, not a function exponent, a function. So now here, which tool shall I use? Obviously, like, I'll prefer using logarithmic functions only. So I'll apply log on both sides. Log of u will be equal to log of x plus 1 by x whole power x. So these are not new things. So log x whole power x, that's going to be x into log of x plus 1 by x. So I think now we can apply differentiation. So I'll apply differentiation. So that's log of u will be 1 by u, del u with respect to x, implicit functions, into, now I'll apply product rule here. So x into derivative of log x. It's okay, I will just write derivative of log of this function plus log of the second function into derivative of log of the first function. Okay, let's continue. So 1 by u, del u by x. Right, that will be equal to x into, what is derivative of log of x, applying chain rule? That is going to be 1 by the function 1 by x. So I have to apply chain rule. That's going to be derivative of x plus 1 by x, plus continuing with the second function, log of x plus 1 by x. What is derivative of x with respect to x? That we know, it is 1. I hope you've written it down. Ready? Okay, shall I rub it off? Okay, please make sure that you get your copies ready, you get your pen, pencils, papers, everything ready, and then as we go on solving problems, you also start noting it down. Okay, that will be better for all of us. Okay, I'll rub it off. So now, let's continue. Okay, del u with respect to x. Now, because I need u by x, isn't it? Derivative of u with respect to x. So u I'm going to multiply up there. So this is going to be x whole divided by this one. I'll take the LCM. LCM is going to be x here because it's x by 1. So LCM is going to be x. So x squared plus 1 into. Now what is derivative of x? That is 1 plus. What will be the derivative of 1 by x? As you all know, you must be already now familiar with derivative. Derivative of 1 by x is minus of 1 by x squared. Okay, minus of 1 by x squared. I'll just rewrite this bracket, doesn't look good. I'll use the second bracket. Plus this, okay, let it be log of x plus 1 by x. Now I can use the other function. What was the function u? The function u was x plus 1 by x whole power x. I'm going to rub this line also. So, chalo, x, I'm taking it out there. X squared plus 1. This will be 1 minus 1 by x squared. As I always say, no, don't go for directly going for the shortcuts and then minimize the steps. My advice in mathematics, if you have time, you can definitely get time. You just have to be steady. All you have to do is write down the steps as much as possible steadily so that you avoid all the mistakes, and then every step is written properly so that you get the full marks during the examinations. Plus, here of course I'll be focusing more on your board examinations or the competitive examinations, and all. For that, of course, I'll bring out some other videos. So here we'll be basically focusing on your board examinations, that is getting the marks. That's going to be log of x plus 1 by x. Board exams are also very important. Okay, so board examinations should not be ignored. So that is going to be x plus 1 by x whole power x. Okay, I'll write x squared plus 1 into this one. If you take LCM, that's going to be x squared minus 1, x squared plus log of x plus 1 by x. Now x squared done. So that leaves me with derivative of the function u with respect to x will be x plus 1 by x whole power x. This is going to be x squared minus 1 by x squared plus 1 plus log of x plus 1 by x. I'll make this, I'll keep this as my second equation, equation number 2. Okay, so my first job is done, because remember, no, I separated the function into two functions, addition of two functions, u and v. So I have to find out derivative of u with respect to x, then I have to proceed to find out derivative of v with respect to x. First job done. Can I rub it off? Okay. Now let's move to the second function, that is and. What was my second function? V. My second function v was x whole power 1 plus 1 by x. Are you done? Shall I rub it off? Alright. Of course you can pause, and then this is the advantage of this offline videos and all. You can pause and then you can always write that once again. Of course I need this equation, so I'll just keep this equation. Okay, I'll just keep this equation, x plus 1 by x whole power nx. No, I'll need this equation, so I'll just keep this for the last. So here, of course, I will take the help of log. So again, log of x power 1 by 1 plus x. I'll just write here, it's alright, not just one sentence. So this comes there, so 1 plus 1 by x log x. Now differentiating, that becomes 1 by v with respect to x, that will be equal to this function, product of two functions, that is derivative, the first function into derivative of the second function, plus second function into derivative of the first function. So 1 by v LE with respect to x. Please ignore this. Okay, please ignore this. This one I'm just keeping it because I'll need that at the final equation. It's equal to 1 plus 1 by x. What was the derivative of log x? Log x derivative was 1 by x plus log x. Okay, derivative of 1, 0. Derivative of 1 by x, we just did that earlier, minus 1 by x squared. So plus minus is minus. I'm just writing it down. Done? Alright. So v with respect to x, that will be v. I'm just multiplying it out there. Okay, if I want, I can. Shall I keep it as it is, or okay, I'll just take the maybe textbook. I do not know what may be the solution, how it may be represented. Minus, because 0 done. So my plus into minus, that's going to be minus 1 by x squared log of x. Alright? Okay. So what is v? Kya tha? X, yeah. X whole power 1 plus 1 by x. This one, x plus 1 divided by x squared minus log x by x squared. We can further simplify this by taking common LCM. Let's just do it, right? So v with respect to x will be x whole power 1 plus 1 by x. Common LCM, x squared. So x plus 1 minus log of x. May be simplified, may not be simplified, that depends, right? It depends on the textbook solution. If it is not simplified, you can keep it as it is. If it is simplified, of course, you can write as it is. That's up to you. Alright. Okay, so this is done. So I'll mark this as equation number 3. Alright. Done. So now let's go back to equation 1. I hope you're done. Shall I rub it off? I'll write slowly. Of course, you can pause the video and then you can note down also. That's the advantage of YouTube and this offline video materials. Alright, now from 1. What was my equation 1? Equation 1 was y with respect to x was u with respect to x plus v with respect to x. So, what was my function? U. What's this one? U with respect to x. X plus 1 by x whole power x. Quite lengthy functions, no? Quite lengthy solutions. X plus 1 plus log of x plus 1 by x plus, this was my second function, plus, you can note it down, plus x whole power 1 plus 1 by x into x minus 1 minus log x, x plus 1 minus log x, x square, done. So that's how it's going to be done, okay, this question. So again, if we just repeat, how was it different? Because this was different in the sense that these functions were like additions of two functions given to us, not just one function where we just take log and then apply logarithmic applications, take the help of logarithmic applications. Here you have two functions, so logarithmic application doesn't give us like log of addition of two functions, no? Log of u plus log of v, we cannot multiply log u plus log v, that's not multiplication, no? It cannot be done. So that's why what we do is, okay, we add a little bit of twist. U and v, we separate the two functions. It can be three functions also, no problem with that. Okay, three functions, so u, v, w, alag alag karke karo na, one function, second function, third function, last mein combine karna hai, bas you just have to combine, na? Alright, okay, so that's it. Then, okay, shall we move? Shall we just try to do one more question? I think it's possible, shall we? No, let's just do one more question. Okay. Okay, I'll do question number 8 because this also has a small twist. This also has a small twist. So this also same addition of two functions, question number 8, okay? NCERT textbooks, of course. So here, without wasting much time, I'll just write u and v. So it's called here del y by del x is equal to del u by del x plus del of v by derivative of v with respect to x. Equation 1, mark and bus. After that, now equation 1. Now u was sine of x whole power x. So I'll definitely take the help of log. Log u will be log of sine of x whole power x. So that's going to be log of u is equal to, visible, right? Yeah. X log of sine x. Okay. So now we can start our differentiation. So done now. Shall I rub it off? Y u v. Okay. So now differentiating. So 1 by u implicit functions, then u with respect to x, that will be equal to, again, product rule, product of two functions, x polynomial and logarithmic functions. So first function, derivative of first and second function, that you can decide here. Okay, differentiation, it doesn't matter much. Plus log of sine x derivative of the second function. Okay, alright, chalo. So u with respect to x, that's going to be u. I'm going to multiply that up there. X, what was derivative of log of sine x? Again, chain rule, no, log of sine x again. So that's going to be 1 by sine x. So we'll continue with our chain rule, that is derivative of sine x plus log of sine x. Derivative of x with respect to x is 1. Okay, good. Of course, definitely you can just check out, there will be more videos on the introduction of differentiations and all very soon. So you can just check those videos. Please, as I say, please do subscribe. I'm waiting for you only, so in the meantime I'm just giving some notifications, no? So please make sure that you note it down. Make sure that you subscribe to my channel if you like my channel here, so that you'll get regular notifications and updates on any video that is being uploaded. Okay, sine x, I'll be uploading many videos, even for lower classes also. I'll be uploading the basic foundation course because that is very important. Sine x, differentiation of sine x is cos x plus log of sine x. So I'll write this here at the bottom so that I'll have some more space for the other function. So that's going to be sine x whole power x. Okay, cos x by sin x क्या था? Cot x, isn't it? Cos x by sin x was cot x plus this is log of sin x. So you can mark, I think that's done. So you can mark this as equation number 2. So you can mark this as equation number 2. Alright, so alright, then can I rub it off? Okay. So now, did I mention you about a small twist with this question? Right, you remember that, no? That's why I said, okay, let's solve this question because there's a small twist in this question, isn't it? What was the twist? Let's see. With the second function. Now with the second function, what do you see here? Okay, do we really need to apply log? Yeah, it's up to you. You can apply log if you want, wherever you want. Who's going to stop you, isn't it? Is it really necessary? I don't think so. It's not much necessary, isn't it? You see, these logarithmic tools and all, we use it when it's necessary. Not that whenever you have to apply, you just have to apply, no. So here I don't think I need to apply log, isn't it? I'll just go for direct differentiation. So it's just chain rule because this can be simply differentiated with respect to x equal to differentiation of sine inverse root of x. What was the differentiation of sine x? Applying chain rule, that was sine inverse x was 1 by square root of 1 minus x whole square. Our value of x is here root x, so it's a different function. So function of functions. So now we continue with the chain rule, derivative of root x. So it's not necessary that you're going to apply log everywhere, isn't it? Wherever it's necessary you apply, where you can directly differentiate, why use log, isn't it? Just apply differentiation directly. So that's going to be 1 by root over of 1 minus x into derivative of root x, a very common derivative, that is 1 by 2 root of x. So okay, I'll just write here. So then b with respect to x will be, I'll just arrange it, right? That is 2 root of x, root of 1 minus x. I'll mark this as equation number 3. Okay. Alright, so that's done. So this was the twist that I was talking about. Finally, now we can go back to equation number 1. So what was equation 1? So from 1, del y with derivative of y with respect to x was derivative of the two functions which we assumed. So what was u here? यहाँ से लाना है, that is sin x whole power x, x cot x plus log sin x. I'll just use plus b with respect to x was this function. So not very complicated, isn't it? You just have to stick to the basics. You just have to stick to the basics. And then, of course, if you want the textbook answer, I can modify the textbook answer, no problem. That is sin x whole power x, x cot x plus, you keep it here also, no problem. Okay, you keep it as it is, not a big problem. But okay, some of you may be wanting to textbook answer se thoda nahi milta hai. Okay, in that case I'll do that. That is 1 by 2. This root x, so root, no, same family, same cert, so we can multiply within that root, isn't it? Right, we all know, no? Root 2, root 3. Kitna hota hai? 2 into 3, that is root over of 6. So we're just going to do that. So x into 1, x minus x into x squared. There you have it. Those who were looking forward for the textbook answer, okay, I think you are satisfied there also. So no problem. You can keep it here also. Okay, it's not a big deal. Okay. This is a continuation of this one only. Okay, since there was no space, I just wrote that. No? Alright then, so that's it. So this is how it has to be done, especially this exercise. There are more questions, definitely I'll come up with more videos to help all of you. So all I request is please stay tuned to my channel, subscribe to my channel, do like if you have liked this particular video, and stay tuned for more videos. Okay, I'll be making lots of videos for all of you. Okay, alright then, thank you all, stay tuned.